So, if you're building any kind of advanced LLM agent, especially for something complex like data analysis, you know how quickly things can get messy. Today, we're going to dive deep into a really critical architectural concept that'll help you move from fragile scripts to truly robust, scalable systems. And that is the registry pattern. Does this look familiar? Come on, we've all been there. You start out with a couple of tools, a few prompts, and the whole brain of your agent is just one giant chain of if-else blocks. And look, it works for a demo, maybe even a version 1. But then you add the third tool, then the 10th, and suddenly you're in a brittle, unmanageable nightmare where changing one tiny thing breaks 3 others. This is a classic growing pain, and it's a huge red flag that you need a better abstraction. Okay, let's really lock in on this because this is the single most important idea we're going to talk about. A registry isn't just some glorified dictionary you use to keep your code tidy. No, it is the control plane of your agent. Think about that. In any serious system, the control plane is the part that configures, manages, and directs everything else. It's the brain making decisions, completely separate from the hands doing the actual work. It's what gives you discovery, selection, and safe execution, the absolute bedrock of high autonomy. So, here's our game plan for today. We'll start by really nailing down the problem, then we'll define the registry as the solution. After that, I'm going to introduce a really powerful mental model for thinking about any registry. Then we'll get practical and walk through 3 battle-tested implementations before we wrap up with the big architectural choice that you have to make. All right, first up, let's get crystal clear on exactly why that messy, ad hoc logic we just talked about is basically doomed from the start. When you're building a truly autonomous agent, the system itself has properties that simple conditional logic just can't handle. So here are the 4 big reasons why that if-else spaghetti code is a dead end. First, the LLM has to be able to see its own tools. It can't reason about capabilities that are just buried in code. You need a systematic way to expose that. Second, your agent needs to switch between completely different modes of analysis on the fly, and you just can't do that if everything's hard-coded. Third, and this one's huge, prompts change all the time. You cannot be redeploying your entire application for every little prompt tweak. And finally, and most critically, real autonomy demands guardrails. We're talking versioning, permissions, audit trails. Your tangled if statements give you none of that. It is architecturally guaranteed to collapse into chaos. And that brings us right to the solution. You have to start thinking of the registry as a control plane. We are deliberately moving away from a chaotic mess of implicit function calls and toward a clean, queryable, and, most importantly, governed namespace. So here it is, the formal definition. Let's break it down. A registry is what registers, indexes, discovers, selects, and manages the lifecycle of all your agent's capabilities. And these capabilities could be tools, they could be prompts, or even entire strategies. It gives the rest of your system, like your planner and executor, a stable API to talk to. You can really boil its entire job down to answering 3 simple questions. Number 1, who exists? What tools or prompts are even available right now? Number 2, where are they? How do I actually get a handle on them to use them? And number 3, how can they be used? What are the rules, the permissions, the constraints? A good registry answers all 3, clearly and reliably. Okay, now we're getting to the core architectural framework of this whole explainer. To really understand registry design and avoid getting lost in the weeds of implementation, we can classify any registry along 4 independent axes. Getting this model in your head is the key to designing a system that won't fall over under pressure. First up, Axis A, the storage model. This is simply about where the registry's information actually lives. The most basic form is just an in-memory map, right? It's fast, it's easy, but poof, it's gone the second your application restarts. A step up is loading from config files like YAML. That's better because it decouples the content from the code. But for real production systems, you're going to see a persistent database or even a remote registry service. That lets multiple agents share the same capabilities and gives you way stronger governance. Next, Axis B, the registration trigger. So how do things get into the registry in the first place? Well, an explicit call like registry.register is super clear. No magic. But for developer experience, you often see more magical methods. Decorators are a huge one. They can register a function the moment it's defined. Or you can set up a base class that automatically registers any new subclass. This is always a trade-off, right? You're trading explicit clarity for that convention-based magic. Axis C is all about discovery. How does your application even find the things it needs to register? Static imports are the most basic way, but they're super rigid. A much more flexible approach is scanning a specific directory for plugins or configs at startup. This means you can add new capabilities just by dropping a file in a folder. And the most advanced systems can even fetch them from a remote endpoint, which lets you do updates without any restarts at all. And finally, Axis D, governance. And let me tell you, this is the axis that separates the weekend projects from the production systems. This is where you handle the really hard stuff. Versioning, so you can safely roll out new tools. Permissions, so an agent can't touch things it shouldn't. And hot reloading, so you can update capabilities with zero downtime. For any serious agent, this axis is completely non-negotiable. Okay, so that's the 4-axis model. It's a really powerful mental map. But now, let's make this way more concrete. We're going to look at 3 battle-tested engineering-grade registry implementations that you can go and build today. And we'll see how they map to that theory. First up is the classic tool registry, an absolute must-have for function calling. See that @tools.register decorator? That's the key. In our 4-axis model, that is our registration trigger. When the Python interpreter loads this file, that decorator runs and automatically registers the described data frame function. But here's the crucial part. It also looks at the function's signature and its docstring to build a schema that the LLM can actually understand. It's clean, it's declarative, and it keeps the tool's definition right next to its implementation. And you can see how this creates a beautiful workflow. The agent's planner just asks the registry, hey, what tools do you have? It gets that list of schemas and passes them to the LLM. The LLM makes its choice, picks the tool and the parameters, and then the agent's executor just uses the registry to look up the actual Python function by name and run it. Simple and powerful. All right, next up, the strategy registry. This solves a totally different problem, how to route between entirely different modes of logic. The key piece of magic here is that _init subclass method in the base class. This is another type of registration trigger. The second you define a new class, like statistical strategy, that inherits from that base, boom, it's automatically added to the registry. This is an incredibly powerful pattern for when you have a family of related but totally swappable components. So the agent's workflow is different here. The planner isn't picking a specific function. It's selecting a high-level strategy name. Then the executor uses that name to pull the right class out of the registry and create a new instance of it. This completely decouples your planning logic from your execution logic. You can add a whole new analysis strategy without ever touching the core agent code. And finally, the prompt registry. This one tackles a huge pain point for all of us, hard-coded prompts. The goal here is to treat prompts as configuration, not code. You can see here the discovery mechanism is directory scanning. The registry just watches a folder for YAML files. The registration trigger is the act of loading and parsing those files. This completely separates your prompt engineering cycle from your code deployment cycle. The workflow itself is pretty straightforward. The planner asks for a prompt by name, the executor grabs it, formats it, and sends it to the LLM. But here's the killer feature, and this ties right back to that governance access. You can build this to watch for file changes. A prompt engineer can go update a YAML file, save it, and the registry can hot reload it instantly without ever restarting the agent. That ability to iterate is a total game changer. Okay, so let's just do a quick summary to tie all 3 of these together. The tool registry uses decorators, and it's all about exposing function schemas. The strategy registry uses subclassing to let you switch between major modes of analysis. And the prompt registry uses file scanning, so you can manage and hot reload your prompts as configuration. 3 different patterns solving 3 very distinct problems. And this brings us to our final and honestly, our most important point. Choosing to implement a registry and how you implement it isn't just a clever coding trick. It is a fundamental architectural decision. It's one that will define the scalability, the testability, and the ultimate safety of your agent. And that's why this quote is so powerful. Being intentional about your system design, really understanding the trade-offs of each pattern, and picking the right one for the job, that's what separates a robust, production-ready agent from a brutal prototype that's just going to collapse on itself. Architectural clarity is everything. So I'll leave you with this one question to think about for your own projects. Are you intentionally designing your registry to be a governed, queryable control plane? Or has it just kind of accidentally turned into an implicit, messy global state that everybody on the team is afraid to touch? The answer to that question is going to determine the future of your agent's scalability and, frankly, your team's sanity. Thanks for joining me.